Hi everyone, this is Hao Yian, and I hope you are all safe and doing well. Today, I'd like to share with you the detail of my 7319 project. So let's get started. My talk is divided into four main sections. First, I will give a brief introduction about the project, like why I come across this idea, what are the perspectives or scenarios in this application, and who will build it, and and also some considerations for the capabilities the project provide. And then I will show the two architecture styles I used and the reason why I chose these two styles and what features or benefits will they provide. After going through the two architectures, I will compare and evaluate the advantages and disadvantages for both styles and make the choice for which to implement the project. Last but not least, I will go over the repository structure and show how I programmed according to the design. I will run the project and look at these features. The project is called Dr. Bob Smith's Online Pharmacy System. You can tell what it does by its name. The reason why I want to build this application is because we cannot go out during the coronavirus pandemic. If someone falls ill in the meantime, buying medicines becomes an urgent problem. And this is an individual project. I built it by myself. And also, the system is not for everyone. It's only for all SMU students, which means you can only buy medicines from this system using your SMU ID. I designed some operational scenarios, which are very familiar to our daily online shopping experience. There will be two roles in the application, student and pharmacist. Students are the customers who can browse the drug list, add the drugs to shopping cart, and also make an order, while the pharmacist performs the role like an administrator who has the permission of checking the orders as well as adding or updating drugs. In addition to these functional requirements, the design also considers non-functional requirements, such as the robustness and the security. There are thousands of students in SMU, although not everyone will buy medicines. And this is also what I don't want to see. And the system has to handle at least hundreds of requests simultaneously. And also, the information, user's information, is quite private and important, so it should not be intercepted easily. Let's look at the first architecture, client-server architecture. I used a design of client-server architecture combined with three-tier and MVC pattern. The whole system can be separated into three parts: client, server, and database. The main functions are concentrated in the server part. It consists not only the MVC components, like controller, model, and view, but also the three-tier components, like business logic layer and the data access layer. I use the MVC because of its excellent encapsulation of separation of concerns, that people only need to work with views when he or she wants to show something, or work with controller when dealing with logic. So what's more, MVC is a high efficiency model. that applications developed with it will be completed fast. But there is a shortage for MVC. All the logics will put into the controller, which makes it complicated. So I added the 3-tier pattern to solve the problem. It separates the logic unit to 3 parts. Controller for the top level, built-in logic layer for the service, and the data access layer for to interact with the database. This architecture is very popular in the high-tech enterprises because of its efficiency and its hierarchical structure. And this is the class diagram of client-server architecture. Actually, this diagram is generated from Visual Studio, the Microsoft IDE. And we can see from the diagram that there are mainly 5 categories: controllers, models, entities, BIL, and DAL, which means data access layer. And every category contains several specific components. For example, the controllers consist of roles controller, logic controller, and also the other controllers. And the BLL layer contains account service, drug service, and also order service. This makes it very clear for developers to implement the system according to the class diagram. And this is a mapping table of components and classes. We can summarize a simple conclusion from the table that different types of components belongs to different directories. Whenever I need to add some new features or business scenarios, what I need to do is to add a new controller and the related service or models. I don't need any other work. It's pretty simple. Let's move to next architecture, the object-oriented architecture. As computer science students, we are pretty familiar with this architecture because so many programming languages like C++, Java, and C# are object-oriented. This architecture is a world of objects and is quite close to our daily life, that everything is an object. As we can see from the graph, all components are abstracted into objects. Connectors among these objects are procedure calls. Although it's quite common, but we can recognize an obvious shortage of this architecture. There are so many lines on the graph, which makes the components twisted together. This makes the project more complex and difficult to maintain it. Also, the class diagram has the same problem. And this is the mapping table. From the mapping, we can see it's quite interesting that the component and class share the same name. This is because the way we represent it in the architecture is exactly the same way as we represented it in the code. Let's look at the 2 styles and compare and evaluate both. For the As we have learned from lectures, the features of the two styles are quite different. For client and server architecture, the central server hosts, delivers, and manages the resources and services to be consumed by the client. All the requests and services are delivered over a network. And for object-oriented architecture, is a world of objects, whose lifetime vary according to use. Using it requires understanding relationship among objects. And for the pros of both architectures, first, the client server, the service is provided by a high-capacity machine and the clients perform simple user interface tasks. And I think this is exactly matches the project requirements. And even though the client-server style has some disadvantages, that it does not affect our project because our project is a small one. We do not need to care about the network boundwise. So I think the client-server architecture is a better choice. There are other benefits of using client-server architecture. First, it's more suitable for business applications like this. People prefer to use web browsers than other applications. And for me, I'm very familiar with this architecture, which means I need less time to finish the project. And also, when using this architecture, there are many popular open source frameworks available, so we do not need to reinvent the wheels. Finally, web applications will be deployed in a web container, and it's natural to deal with concurrency issues. And this is the compile result. As we can see below, this is the build information, and I use Visual Studio 2017 to build my project. And from the right side, we can see there are different folders for different logic sections. The BIL for services, the controllers for all controllers, and also the DAL. And this is the entity framework, which is an OR mapping tool by Microsoft. And I also use the SQL Server 2019 or 17 to be the database. And there are file tables to support this application. And there are some screenshots for my application. This is the plugin, and this is the drug list, and this is shopping cart, and also this orders. Because we just to implement our design architecture, so I pay less attention to the appearance, so the pages may seem not so beautiful. Forget it. Okay, let's run our application. Yeah, this is a drug list, and we don't need to log in. So this is the name, this is type, price, remaining count, and description. If we want to buy something or want to edit something, we need to log in. So let's click on the login button. Cool. And first, let's use the student account. because not saying. Okay, so this time we can see this button. It means to add this drug to my shopping cart. Let's look at my shopping cart first. It is empty, so I cannot click on the buy button. Let's go back. So this time let's add this drug for 1. Oh, cool. For 2. Amazing. For 3. Yeah. And let's see the shopping cart. Yeah, it's 1, 2, 3, totally 6, and this is the total price. So let's buy it. Okay, so this is the latest order, and this is the previous orders. So right now, let me sign out to change the account. This time, let's use the account of the pharmacist. Okay, so we can see there's a new button. Yes, we can create a new drug, but I will not do it. And we can check the orders here. So the student 81 have these orders totally, and it's ordered by the order time. Okay, that's all. Thanks.